D-Lab myth busting. Can you use a 2E26 transmitter tube as an audio amplifier? Yes, you can, and here's how you do it. So there's a lot of articles and people in forums talking about, hey, can I use the 2E26 as an audio amplifier? A lot of people have tried it with disastrous results, and there's one main reason, and that's because they didn't read that tube data sheet. If you look at that, you'll see that the bias voltages and current settings on that tube are critical, but if you get it right, it's a great tube. So you may think, well, what was that 2E26 used in originally? Usually military type transmitters, and Collins Radio actually incorporated it into an exciter. I just happen to have one right here. Let me show you under the hood. Alright, so here it is, the Collins 310B3 exciter. Now these things were used by hams to drive big old amplifiers, or they actually use these standalone as cool little QRP transmitters. So we'll go under the hood, and there is the little tube layout, and if you look right over here, you'll see 2E26. Where is he? Well, he's right down here. And he works with these variable coil assemblies and variable caps to tune it as an RF output tube. A very reliable tube, and later on it was replaced by the higher current model called the 6146. Anyway, we're not going to go into that. I just wanted to show you one application of this tube. So to prove out whether I could use the 2E26 as a Class A amplifier, I built it on this little Hammond chassis. Over here is the preamp tube, a 12AX7. There is the 2E26 with its little plate cap for the high voltage. Output transformers right here, which is an 8-watt type. And to keep this tube under control, I used an OA2 voltage regulator. This keeps 150 volts constant on the screen of that tube. And if you read the tube data sheet, you'll see all kinds of notes. Do not exceed 200 volts on the screen of the 2E26. So to me, the easy solution, the OA2. Let's go underneath and I'll show you how it works and how it holds that voltage on the screen. So for this project, I wanted to shoot for about a 5 to 6 watt Class A amp. Right? So my power transformer delivers 276 volts, and you can say I use diodes for the rectifier. Then the screen voltage goes through this 5.6K 4-watt resistor. It hits the OA2 tube, and that's being held at 151 volts. You may say, well, I could probably do that with some resistors and just do a voltage divider. Well, you can, but as you play and this amp draws current, that screen voltage is going to vary and cause distortion in your output. Okay, so that's the beauty of the OA2 regulator. That goes through this 10 ohm resistor, hits the output tube right here. There's my 150 volts constant on the screen, and if you look at your tube data sheet, you can see 200 volts is the max. So we are well within the safety limits. All right. Now here, this big guy is a 250 ohm 10 watt resistor, and he's going to the cathode of the output tube to set the bias. And I was shooting for about 40 milliamps. So we got, let's say 9.8 volts, right? So 9.8 volts divided by 250 ohms gives me about 39.2 milliamps of current through the tube. And it seems to do a great job. The thing's been running for hours, purrs like a kitten. So now, let's hook up an audio generator and take a look at the output with the scope. So here's my typical test setup. Amp, dummy load, scope. Behind here is a WaveTech audio generator. And we're going to keep monitoring that screen voltage with my Beckman so that you can see how well it holds steady regardless of how hard you drive the amp. And the star of the show is this B&K scope. It's a model 1460. I actually had one of these when I was in the Air Force, and I got lucky and found this one new in the box. Believe it or not, had never been used. So she's El Minto. It's a 10 megahertz single trace scope absolutely perfect for working on these old amps. Alright, so here we go. I've got the signal applied. Bring up the volume, and you watch over there on the scope, and there is one gorgeous looking sine wave. I'm at about 750 Hertz. I can crank up the frequency. And now, let's crank up the gain and take a look at the distortion, because I know you guys want that Class A distortion, right? So here we go. Now that is just the volume. You can see a little bit of breakup. Now I'm going to take the treble all the way up, since we're at a higher frequency, and let's see what that does. Look at that baby. So this should be one heck of a great sounding Class A amp. You can see she stays nice and clean when you want it to, and if you crank on it, bam, she distorts beautifully. So the 2E26 is doing a great job. So far so good, huh? It's quite obvious that the 2E26 is a great Class A amplifier. And if you do a little bit of research, you'll find that some of the old transmitters back in the day would actually run a pair of 2E26s for modulators. So they're push-pull amplifiers for audio. Even though they're mainly used for RF output tubes, they did use them for audio. And the other cool thing is they're cheap and they'll outperform any 6v6 because they can really handle some current. Alright, so now let's myth bust the other thing I read about. There's another tube out there. It looks just like the 2E26. It's called a 2E24. And all the articles are saying that these are interchangeable because the only difference was the 2E24 had a quicker filament on time. Alright, they had a center tap on there, so they did some magic there so that this tube would activate quick for military type transmitters. So the question is, would this thing bias the same in that amp as the 2E26? Let's give it a shot. So here we are again. Still monitoring that screen voltage, but I'm going to take my Proberino. We're going to go back over to the bias resistor. Alright, so we're still at that 9.7 volts. Now this is the 2E26 that we have installed. Now we're going to swap it out with the 2E24 and see if the bias remains the same. If so, it'll probably work just like the 2E26. If not, you're going to have to rebias the amp. Let's take a look. I'm pulling the tube out using a little washcloth because she is hotter than a firecracker right now. That's the cool thing about Class A, right? They're sitting there running 100% duty cycle. Man, that is one tight socket. I did use an old stock cinch socket on there. So here's the oh, that's 2E26. We don't want that one. Here we go. 2E24. Okay. Get in there. Pop him in. Be cautious when you handle your plate cap, because that guy could bite you. That was another reason that they went to like 6L6s and 6V6s, because the plate caps weren't exposed. I just plugged it in. She's warming up. Now look at my current. Only got like 3 volts, right? So 3 volts, guys, that is not going to have the current that we had before. So 3 divided by 250 ohms, now I'm down to 12 milliamps of current. So for the heck of it, let's unplug it. Let's put back in my original 2E26 and make sure, man, that jobber's tight. Get it out here. Boom. Okay. Put in my original 2E26. I know you can't see this. It's all back behind the scenes. Kind of like the Wizard of Oz, right? I'm back here pulling cables and making lights and horns go off. And you guys are like, where's that coming from? Alright, 2E26 back in. Plug this guy back in. Here comes the bias. Now you can see it is a much longer warm-up on the 2E26, so it's not false advertising that the 2E24 has quicker filament heating. Right back to 9 volts with the 2E26. So I'd say no, you cannot put the 2E24 as a direct replacement without rebiasing your amp. Otherwise she's going to run cool as a cucumber. So there's some super cool information. Now take a look at this. Here's the cabinet for D-Lab's Boutique, or is it Boutique amp? I don't know. I have people asking me, why are you saying Boutique? Well, why do some people say washer and some people say washer? Potato, potato. I don't know. I'm from Michigan. Sometimes I talk funny. Anyway, this project is a huge success, and now I'll post the schematic for you guys to take a look at. So if you want to build one, here it is. So here we go. Here is the schematic for the 2E26 Class A amplifier by D-Lab Electronics. If you take a look at the schematic, you'll see it's pretty basic. The preamp section is pretty much what I do on all these little Class A amplifiers. Alright? The main difference would be, of course, the 2E26. And then if you look down to the right, you're going to see the OA2 voltage regulator. And to the left of that, you see that 5.6K 4 watt resistor. 4 watt is the minimum, alright? Don't try to put a 1 watter in there, you're going to smoke it. That resistor has to actually drop 125 volts across it, right? Because the voltage regulator needs to pull enough current to maintain 150 volts. And that current is shared with the screen of the output tube. So you have to select that value carefully. So if you were to build this amp and say, well, I want to run 350 volts plate, you are going to have to select a new resistor for that screen dropping resistor to the OA2 regulator. Alright? If you don't get that right, it's not going to work. Alright? So I had to kind of play around, do some calculations to get that value correct. But if you want to clone this amp, the information is staring you right in the face, and you're going to have a great little Class A amp. Alright, so D-Lab does it again. I'm giving you guys free information because you know what? I can't build all these amps, but what do we got going out here? I see a little snow pig outside. It's like 15 degrees out. He's out there shivering. Let's let him in. Come on, buddy. So I hope you enjoyed this little presentation, and hopefully this clears up the information about the 2E26 tube. Can it be used for audio? Yes, as long as you pay close attention to the information on the tube data charts and keep the screen voltage under control. You can build a very cool little Class A amp.